So this is a non-calculated question. You have 2 minutes, go.
I know, but yeah, I was gonna say all that. Okay.
One more minute. Any ideas?
I got C. Yeah, so
Anybody else get C? Anybody get something other than C?
I got D.
You got D? All right, let's take a vote. Who thinks it's C? Raise your hand. 2 people. Who thinks it's D? Person. Other answers? None of the above? Okay. You got A? Any other votes? Okay, the answer is C. So this problem should take you like 30 seconds, okay? Remember the concept is you have a function, f of x, and its inverse, g of x. Remember that if there's a point here whose coordinates are a, b, then there's a corresponding point here whose coordinates are b, a, right? And if you take the derivative at this point, it's the reciprocal of the derivative at this point. So in this problem, f, we know g of 3 equals 1. That means this is the point 3, 1. This is not the scale, obviously. This is the point 1, 3. So if we're trying to find the derivative of g at 3, it's the reciprocal of the derivative of f at 1. So this is really g prime of 3 is really 1 over f prime of 1. Does that make sense? So that's easy to calculate. F prime of x is 3x squared plus 2x plus 1. F prime of 1 is 3 plus 2 plus 1. So the answer is 1/6. Does everybody understand that? The most common distractor answer here would be, I think, A. That's what you get when you find f prime of 3 and take its reciprocal. Is that what you did? Any questions on that? So the derivative of an inverse is the reciprocal of the derivative of the function at the y value of the function point. Okay? You gotta make sure you switch that point. All right, let me fix this. Okay, so the other day we talked about average value of a function. Remember, the whole concept was the average value of a function over an interval is 1 over b minus a, and the integral from a to b, that affects dx. Any questions on problems like from Delta Math or anything like that?
I just have a hard time doing the trig values when like there's like a lot inside the, like if it's cosine like 3x squared plus 2x, I just have a hard time doing that. Like when there's multiple.
Okay, you want to do some problems or? Okay, so there was a section on Delta Math for trig. Gotta find the assignment. So do this one here, I assume. Okay. So that one's not too bad, right? Let's do one that's a little harder. Too bad.
The ones, go back to like the last section, I think.
Which section?
The average rate of change.
This one?
That one, yeah, that one had like, but.
Oh, I got you. Okay. All right, so we want to do this one? Okay, so it says this function is defined by this long expression. If the function g is defined to be this, what's the average rate of change on the interval from the use calculator? All right, so let's just use calculator. So the first thing I would do is I would substitute that in for y1 on my calculator. So I have x squared minus 2x plus 4 sine of x squared plus 1. Okay, so then just make sure that like you didn't have any typos on your calculator. Everything looks good. Make sure your calculator is in radians. It is. So now I don't ever have to type this in again. Now let's look at the question. The question is saying if g is defined to be the integral from 0 to x, what's the average rate of change of g on the interval from -1 to 5? So the average rate of change of g would be it would be g of 5 minus g of -1 over 5 minus -1, right? So all I need to do here is do this on my calculator. But g is a definite integral. So on my calculator, I'm going to do parentheses, math 9, the integral from 0 to 5 of y1, variables, y variables, function 1, x. So that's g of 5, minus g of -1, which is math 9, the integral from 0 to -1 of variables, y variables, function 1, dx. So that's the numerator of that. I'm going to close parentheses, divided by 6. And that's it. So the answer would be 4.152.
I think my problem was that I didn't use my calculator to do like the integral. Like I would do that out and then use my calculator for simple computations, like just subtract.
Oh yeah, use your calculator. Definitely use your calculator. Especially on this one, like this is not integrable. Like if it was just this piece right here, this is not possible to integrate by simple means. Like you can't do this by hand.
Yeah,
so
that's why I was having so much trouble.
I would do it. Yeah, it says right here, you may use calculator. Definitely don't forget you have a calculator and use it to solve equations, use it to do derivatives at a point, use it to do definite integrals, like use it to find points of intersection, use it for all those things if you have it available to you, because they expect you to, and you'll definitely save time. Does that help? Okay. All right, so today, we're just gonna talk about motion problems again, okay? So I think we're actually able to do pretty much any motion problem we encounter, but it's covered again for some reason in Unit 8, so I'm just gonna cover it again, and we'll just do some simple problems and make sure everybody's on the same page. So this is just motion problems we visited. So rather than like summarize things, I think we'll just do a couple problems to make sure that we're able to do that. Okay, so what if we have a problem that was like the velocity of a particle or whatever is given by the formula arctangent of t squared plus t minus 1, and x of 0, position at 0, is 0.085. And they said, find the displacement from t equals 0 to t equals 5. So what do? How do you find displacement? I can't hear you. Okay, what do you mean?
If you have the displacement at 0, and then you do that
We have position at 0. This is position. So generally, what's the displacement formula? The integral of what? Yeah, I mean, that's it. It's just generally the displacement formula is the change in position, right? So displacement over an interval is just the position at B minus the position at A. It's just that, right? It's change in position. That's it. So we can get that in a couple ways here. We can use FTC part 1 to find x of t. We could do that. This is like an initial value problem. We could do that. It would be a little bit time consuming though. A better way to do it would be to just take the integral from a to b of t. Because if you think about what that is, it's just x of b minus x of a. It's exactly what we want. This is not really necessary. Like, we don't really even need to know that. Does that make sense? So I would just use my calculator here to find the definite integral of this function from 0 to 5. So on the calculator, Math 9, definite integral from 0 to 5. And the function would be second tangent of x squared plus x minus 1 dx. And units. That's it. Does everybody understand that? So if this was a free response question or whatever, and I had to show my work, all you have to do is just say, you can't just have a calculator answer like without the setup. So all you have to write is the integral from 0 to 5 of b of t equals the answer. So in this case, it would be 5.504. And you don't have to write the function out because they already gave it a name, v of t, so you can just refer to it as v of t. Okay? Let's do more. What if they said, v of t equals x cubed, or t cubed rather, minus 3t squared plus 2t, and the position at 0 equals 4, and they said find the total distance traveled. From t equals 0 to t equals 3. So first of all, how is that different than displacement?
Total distance traveled, like displacement's like down.
Other way.
Total distance, like. Words.
Yeah, I think you're on the right track. But like, if I'm walking back and forth in front of the classroom like this, and I start and end up here, then my displacement is 0. My total change in position is 0 from when I started to when I finished. But my distance traveled isn't 0. I was walking back and forth the whole time. So how do you calculate total distance traveled? That's the question. What do you think? Well, I mean, what if the velocity function looks like this, v of t? And I'm trying to calculate distance traveled between A and B. What would that correspond to? Yeah. Yeah, okay, so in this case, distance traveled would be the integral from A to B of v of t. All right, case 2. What if the velocity function looks like this? And I'm trying to calculate the distance traveled from A to B. What? Well, this integral would be negative. Yeah, it would be the distance traveled would be the negative integral from A to B of v of t. Agreed? Because distance traveled can't be negative. You can travel a negative distance, right? Okay, case 3. What if you have a function, a velocity function that goes like this? Sometimes it's negative, sometimes it's positive. And you're trying to calculate the distance traveled from A to B.
So would you have to like find zeros and then
Yes.
like add it all up?
Yeah, okay. So the distance traveled, in this case, would be, let's just simplify this like if this is A and this is B and this is C. It's going to be A plus B plus C in area, right? So a way to get that, there's a couple different ways to get that. One way you can get it is, like you said, find the zeros of the velocity and calculate the integral in between those zeros. If that area, if that integral happens to be negative, just make it positive. And then if it happens to be positive, just keep it positive.
Would it be A plus absolute value of B or no?
I'm just saying B is an area, so it's positive already. Yeah, yeah. So I spelled this wrong. So another way to get this, though, is I could just take the integral from A to B of the absolute value of v of t. Because think about what absolute value of v of t would look like. It would be, the stuff that's positive would be the same. The stuff that's negative would become positive. and the stuff that's positive will stay the same. So you'd really be taking the area under the curve of this blue stuff, which is all positive. Does that make sense? So that would be kind of the best option if you have a calculator, okay? You could just take the integral, like in this problem here. I could just take the integral, Math 9, of from 0 to 3, of the absolute value of that function. So I could do math num absolute value x cubed minus 3x squared plus 2x dx. So this would be the best way to do it if I had a calculator. 2.75. 0. So the integral from 0 to 3, the absolute value of b of t, dt, is 2.750. That's the best way to do it. Now, what if this was a non-calculator question? Then we'd have to do it the A, B, C way. We'd have to find the zeros of the velocity, which would be t cubed minus 3t squared plus 2t equals 0. This is solvable pretty easily without a calculator. T minus 2, t minus 1. So t equals 0, 1, and 2. And then take three separate integrals. Take the integral from 0 to 1 of b of t and its absolute value, plus actually only two separate integrals. The integral from 1 to 2, bless you, b of t dt.
Wouldn't it be 3 though, because we're going to 3?
Oh, were we?
Have to do it.
Oh, 3, okay, yeah. Yeah, you're right.
Plus,
So then plus the absolute value integral from 2 to 3, b of t dt. So yeah, you have to do this work if it was a non-calculator question.
You can get into the calculator without the absolute values just to see how the answer would be different.
It would definitely be different. Like if I take Math 9, the integral from 0 to 3 of x cubed minus 3x squared. And by the way, if this was a multiple choice question, the most common wrong answer would be this answer right here. Right, it's 2.25. And that's because if I graph the function, if I graph x cubed, I wish I would just type this in at the beginning, but x cubed minus 3x squared plus 2x. If I type this in and I just look at it between 0 and 3, so I change the window to go from 0 to 3, and then zoom fit, you can see sometimes it's above, sometimes it's below. So what it's doing basically is this and this, like this negative stuff, this probably isn't symmetric, so it's not like they cancel each other exactly, but this negative stuff is going to cancel out some of that positive stuff that you really want to count. Okay, so that's why you get an answer that's kind of close, but not exactly, because the stuff that's above, like this stuff right here, in area is much larger than like this little piece right here. So that's why the answer isn't too far off, but it's definitely not right.
So that 2.25, that's the displacement of this.
Correct. Yeah, that's the displacement. Okay, let's just do one more type of question, and then we'll look at a free response question that deals with motion. So how about this? What if we have the acceleration of a particle is given by the formula 12e to the negative 2t plus 18t. The velocity at 0 is 2, and the position at 0 is 4, and we're trying to find the position at 2. And let's say this was a non-calculator question. So what type of problem is this really? Okay, so rather than ask that, what do we do?
Don't we have to like integrate the acceleration and find the c and then do it again?
Yes, exactly. This is like an initial value problem. That's what I was looking for when I asked that previous question. This is an initial value problem where they're giving you the second derivative and two initial conditions. So you got to do it in 2 steps, right? So you take the integral here, so you get v of t is equal to 12e to the negative 2t divided by negative 2 plus 18t squared over 2 plus c. Now we're going to use this initial condition to get the value of this c, right? So I'm going to have 2 equals negative 6 times e to the 0 plus 0 plus c. But e to the 0 is 1. So if I add 6 to both sides, I get c equals 8. So now I have v of t equals negative 6 e to the negative 2t plus 9t squared plus 8. Now start over. Integrate both sides. X of t, position at t, equals negative 6 e to the negative 2t divided by negative 2 plus 9t cubed over 3 plus 8t plus c. Different c, of course. I'm going to use this initial condition to find the value of this c. So I have 4 equals 3e to the 0 plus 0 plus 0 plus c. Subtract 3 from both sides, so c equals 1. So now I have a position function, x of t equals 3e to the negative 2t plus 3t cubed plus 8t plus 1. Now I can just plug 2 in. X of 2 would be 3e to the negative 4 plus, if I plug 2 in, I get 24 times 8 plus 16 plus 1. There's the answer. So this was just an initial value problem. Everybody understand that? All right, let's look at a free response question that deals with motion. Yeah. I gotta find it again. All right, 1 second. What's that?
Is it just the first one, the opposite on the top?
This one? No, that's the problem with the data we did. It must log you out automatically because I had it all.
Right. And it's after 1 second hour.
Why is it taking so long? Hang on, just give me 1 second. All right, got it. Okay, so this is a free response question that deals with this topic. All right, so it says, Emma and Lily jog along in the same direction along a straight track. For t between 0 and 15, Emma's velocity is given by this formula. Lily's velocity is given by this formula. Let's just plug these values into the calculator right away. So I'm going to substitute in E of t for y1. So it's 7510 divided by parentheses x squared minus 7x plus 80.22.
Thanks for reminding me that we can do that, 'cause I kept trying to store an equation that's like A, but then it would just give me the answer to the equation wrong, so.
Oh, yeah. No, you want to solve, put them in as y1 and y2. And then L of t is 12 x cubed times e to the negative 0.5x. Okay, so there's my two functions. I don't ever have to type them in again. All right. It says both E of t and L of t are positive for t between 0 and 15 and are measured in meters per minute, and t is measured in minutes. Emma is 10 meters ahead of Lily at time t equals 0, and she remains ahead of Lily for the whole time. Okay. So it says find the value of 1/6, blah, blah, blah. That's easy to do on your calculator. Okay. Interpret the meaning of 1/6, the integral from 2 to 8 of e to t in the context of the problem. So what is that? What's the answer to that? That's not the answer they're looking for. You might get credit for that, but I doubt it.
What did she say?
She said it's 1/6 of the displacement of Emma between t equals 2 and t equals 8.
Average.
Yes. Average what?
Average relation.
Of, no, average, no, it's not average position, average value of what? Yeah, if E of t is her velocity, this is the average value formula of that function. So this is Emma's average velocity, and the units would be meters per minute, right? Between t equals 2 and t equals 8. Agreed? So this is just what we did last time.
Wait, really? With the average velocity and not the average position?
It would be average velocity. Because think about what it would be. If you take the integral of velocity, you get position, right? This would be her position at 8 minus her position at 2 divided by 8 minus 2, which is average velocity formula. Position at B minus position at A over B minus A, average velocity. So this is her average velocity in meters per minute between t equals 2 minutes and t equals 8 minutes. That's what they expect you to write, including all the units. Okay? Part B, it says at time t equals 5, is Emma speeding up or slowing down? How do you answer that question? You remember? Yes. You find E of 5, which is her velocity at 5, and you find E prime of 5, which is her position at 5. So your calculator can do that for you, right? All you need to do is from the main working screen, remember E is my Y1, I think? Yeah, E is Y1. So I'm just going to do math 8. Actually, hang on a second. Let's look at the graph first. So from 0 to 15, zoom. So from this, I'm going to do second calc value. I'm going to find the value of y1 at 5. So x equals 5. So this is the value of y1 at 5. It's positive. It's 106.949. I can actually find the derivative from this screen as well. I'm going to do second calc. It's just dy dx at 5. at x equals 5. And dy dx of that function, well, I don't know, is this y1 or y2? If you toggle up or down, that's y2, so this is y1. So it's negative, definitely decreasing. So what you would say is you would say d of 5 equals whatever it was, I didn't write it down, which is positive. A of 5 is whatever it was, I didn't write it down, which is negative. So you'd say, so since the signs aren't the same, then Emma is slowing down at t equals 5. Does that make sense? Okay. The next question then says, is the distance between Emma and Lily at time t equals 7 increasing or decreasing? How do you get that?
Whatever the E of 7 is and L of 7 is, and then whichever one is straight up.
Yeah, exactly. The distance between them is changing at a rate of E of t minus L of t. Right? That's the rate at which the distance between them is changing. So you just find E of 7 minus L of 7. If that happens to be positive, then the distance is increasing. If it's negative, then the distance is decreasing. Right? And then the last question, what is the maximum distance between Emma and Lily over the time interval from 0 to 15? How do you calculate that?
The first derivative test of that equation that you just wrote.
Yeah, I know that E of t minus L of t is the rate at which the distance between them is changing, t prime of t, right? That's the rate at which the distance between them is changing. If I want to know what the maximum distance is, I do the first derivative test. I set this equal to 0, determine when they're equal, and then do a little first derivative chart to see which one's the maximum. So my chart, I mean, I can see from my function that there's 2 points of intersection. My chart's going to look something like this. It's going to be 0, 15, 2 points of intersection. In that first little section, E of t is greater than L of t. So this is going to be positive. Difference will be positive. Then it's negative, then it's positive. So the maximum is going to occur either at this point of intersection right here, or at 15, right? Those are the potential absolute maxes. All I need to do then is just figure out which one is the absolute max. How do I figure that out? How do I find, for example, the position at time 15, or the position at time whatever that intersection point is? How do I find the position at a particular point? Yeah, we could do second derivative, or FTC part 1 rather. We know, actually we don't know their position, but we know that Emma is 10 meters ahead of Lily. So let's just assume that Emma's position is 10, for example, and Lily's position is 0 at that moment. Then just do the first derivative of FTC part 1 to figure out Emma's position and Lily's position at each of those times, and compare them and see which one's further apart. That make sense? Okay. All right, that's all I got. So for homework, it's in Delta Math, and it's called motion problems again. Okay? I'm going to stop recording here.